Hello. So the first derivation of rotational dynamic is this: vehicle along a horizontal circular track. Remember, uh, remember that for every derivation you just need to first see the diagram. Practice the diagram. When you draw the diagram, the theory part of the derivation you can write with the help of this diagram. So this is your diagram. You can say that this figure shows the vehicle on a horizontal road where C is the center of the track, and the forces are weight mg, which is vertically downwards, and the normal reaction, which is vertically upwards. And this upward and downward forces, they balances each other. And for horizontal, there is force of static friction. This static friction, it prevents a vehicle from outward slipping or skidding. And this static friction is always balanced, the horizontal part is always balanced with the centripetal force, which is mv square upon r or m omega square r, whichever is the required. So when you start the derivation part, see, from the diagram you just speak that fs is equals to mr omega square, which is the centripetal force. So m r and omega is nothing but v upon r. So this is a square part, so v square upon r square. We got this from here, v is equals to r omega. And so fs you got mv square upon r. The second part is n is equals to mg. So n is equals to mg. When you take the ratio of these two, that is fs upon n, you get mv square upon r upon mg. When gets cancelled, this g becomes here v square upon rg. So fs upon n is nothing but mu s. Mu s is the coefficient of static friction. So v square upon rg, you want v, so it goes there. And when you take out the root, v, you got v max is equals to mu s rg. This is the speed required for the vehicle along a horizontal circular track. Now this is the second derivation, which is the vehicle along a bank road. So this is the definition of banking of roads. You must write this definition in this derivation. Again, the diagram part. This is the diagram of a vehicle on a bank road. So the forces here are weight mg vertically downwards, and the normal reaction. The normal reaction is again divided into two: the n cos theta, which is vertically upward, which is balancing the weight mg, and n sin theta, which is horizontally, which is balanced by the centripetal force. Okay, so this is what I told is written here. So when you start the mathematical form, you're going to write that n cos theta is equals to mg, and n sin theta is equals to mr omega square, which is again mv square upon r. When you take the ratio of this two, n cos theta upon n sin theta, mv square upon r and mg, whatever gets cancelled will cancel. You get sin theta upon cos theta is tan theta. So you get tan theta is equals to v square upon rg. If you want the speed, that is v, then v square is equals to rg tan theta. And when you take out the root, you got v is equals to root rg tan theta. This is the safest speed along the bank road. And if you want a banking angle, the banking angle is theta. So when you v square upon rg and tan inverse, so theta is equals to tan inverse v square upon rg. This is the most safe speed, and this is the banking angle along the bank road.